A major concern when arranging pipe in a rack is the amount of expansion and contraction that occur when a cold pipe is heated to its normal operating temperature. Because the dimensions provided in the line spacing chart do not account for expansion of a pipe during the startup of a unit, consideration must be given to the amount of expansion a pipe will undergo as its temperature begins to rise. Linear expansion correlates to the direction of flow. In other words, a pipe will grow in the same direction as the fluid flows. This is depicted here in this example. If the expansion of a pipe will result in its interference with an adjacent pipe, line spacing will have to be increased. If the normal expansion of a pipe will not result in interference, line spacing will not be affected. Remember, space in the rack is limited. Overspacing must be avoided. In the following figure, we will provide a simplified illustration where additional line spacing may be required. Here we have 4 150-pound rating pipes. Pipe 101 is drawn double line as its nominal pipe size is above 12 inch. Pipe 102, 103, and 104 are drawn single line since their nominal pipe sizes are below 12 inch. The arrows that you can see here indicate the direction of flow. Line 103 and 104 have similar spacing in the rack. Both pipes drop down in the rack, then turn west to rest on a support beam before they exit the pipe rack and presumably attach to a piece of equipment. Now, using the space dimension provided in the line spacing chart that we have seen in the previous video, we can see that 8 inch is required between the center lines of the two pipes when they turn west. Now, let's assume that expansion calculations indicate that line 103 is expanding 2 inch to the south, and line 104 is expanding 2 inch to the north, as highlighted here. By adding 1/2 the outside diameter of line 3, which is 2 1/4 inch, and 1/2 the outside diameter of line 104, also 2 1/4 inch, and the 2 inch of expansion for each pipe, we will obtain a total of 8 1/2 inch. It becomes obvious here that an interference or clash between lines 103 and 104 would occur at point 1. To avoid this interference, two alternatives are feasible. The first option consists in increasing the spacing between the two pipes if possible. Notice here that I said if possible. Why is that? Because perhaps the ends of these pipes are connected to a downstream equipment, and increasing the spacing is not an option. In this case, we can use option 2, which consists in cold springing the two lines 1 inch. Cold spring, or shortening, is an installation technique that requires the length of the pipe that is expanding to be cut short by a distance equal to 1/2 of the length of expansion. In our case, it would be 1 inch for each line, since each line is expanding 2 inch. This is how we usually solve interference problems occurring between two adjacent pipes following a thermal expansion. Now, as an exercise for you, and before moving to the next video, try to figure out how to solve the interference problem for line 101. Here, an interference is likely to occur between lines 101 and 102 at point 2 if line 101 expands 5 inch east.